Okay, here I go. I'm gonna demonstrate how this TD-4 4-bit computer does conditional branches. Again, you've got the ROM, which is hard-coded, and then you've got your output, which is this 4-bit output. You got a 4-bit input. You've got a clock. You got an ALU, which is just an adder. It's a 4-bit adder. You've got A register, B register, program counter, and your output port. Your output register, which is just linked directly to that. You've got chips for decoding your instructions, and I penciled in a no op, which is basically all zeros. If you were to add 0 to the accumulator, nothing happens, and that's great, because if you needed to make a little space in your program for adding something later, this is an operation that you could do that has minimal effect on everything else except the program counter. You have not a rich set of opcodes, but you can add an arbitrary number to the A register. You can move the B register into A. You can input using this 4-bit input into the A register. You can move an arbitrary number into A. You can move A register, copy A register into the B register. You can add an arbitrary number to the B. You could input to B, same as the A, using those. You can move an arbitrary number into B. Yes, and let's see. Move, and let's see. You can output B to the 4 bits. You can output an arbitrary number into the 4 bits. And you have a jump with 0. So this is your conditional jump, and then you have an unconditional jump, which is just affects the program counter. So the jump with 0 will check to see if there was a carry bit or not, and I got to tell you, this is not a well documented instruction. Took me a lot of trial and error to figure out what was going on in here, anyway, I believe I've got it now. So what we're doing here is pretty simple. We're going to put the number 7 into the A register, and then we're going to add 9 to it. So 7 plus 9 is F, right? So there is no actual carry if it's just F. So jump if carry to step 6, but in this case we're going to ignore that, because there's that statement is not true. So it's going to blink bit 1, which it's doing. It's going to blink it on and off, and then it's going to jump back to 0. Again, now what we could do is we could change this 7 to an 8, or we could add anything that exceeds F, and then which is going to then create a carry, and then we will skip over the blinking of bit 1, and we will blink bit 4 instead, and then we'll jump back to 0. So the codes are entered. Let me get you nice and close here. So the bits are 7, 6, 5, 4 are the instruction, and 3, 2, 1, 0 are the the number that you're, the data that you'd be working with. And then, if there's, so like for example, FFFF is jump, and then 0, 0, 0, 0, 0. So you can see on here that step number 0, 1, 2, 3, 4, 5 says jump back to 0. And then and this is this is the jump. This is the conditional jump, and this is an unconditional jump. It's all again, not terribly well documented, and unless perhaps you speak Japanese, I think it might be a lot better documented, but This is the best I could get. So let's see what we got going on here. So we're adding 7 and 9, and we're not getting a carry. So let's add 7 and 10, and now we've got a carry. So that adds to 17 instead of 16. So let's do this. Let's say 0 plus FFFF, no carry. 1 plus FFFF, carry. So there you go. And then we could take the 1 away from here, and you got a 1 plus, basically 15, and it works out to 16, and or F, and no carry. Carry. So I don't know if I'd really call this a computer. I suppose it is, but the lack of RAM is, I think, the fact that it only has 16 possible instructions is, or ROM locations with about 15 possible instructions. I mean, that's fine. You could make a computer out of that, but and the ALU is, you can add in order, you can add to subtract and all that. So it is a computer in that sense, but with the lack of RAM, it's a little. I don't know if it fits the definition. I suppose it's by the strictest definition of what a computer is. I suppose it is. But I think not having RAM is problematic. I don't even know if this would be without the RAM. This is neither a von Neumann or a Harvard architecture, because with the differences there, you would have a different bus for the RAM and for the ROM, and in this case we don't have any RAM, so there's only one bus, and it's ROM only. So I don't even know what architecture you could call this. But it is a 4-bit computer, and it does conditional jumps and does some basic math. So here we go.